Today we want to talk about base E and natural logarithms. Really, this is not changing the way we're going to do much of anything or anything that we've done in the past. It's just going to introduce us to this letter E. And what does it mean and what does it stand for? E is denoted by lowercase italics e, that would be E. And E is simply referring to an irrational number. That number, rounded, would be a 2.71828, etc. Okay, you can recall from your understanding of irrational numbers. Irrational numbers are numbers that, when shown as a decimal, never repeat and never stop. They also cannot be shown in fractional form. How will we see E used? We will see it used as a base, so e to the x, and we'll also see it as the base then of a log. So you could write log base E of something, but instead we will use a more common form, which is just the ln. So anytime you see ln, what does ln really mean? It really means log base E, which means all of our logarithm rules would still work with an ln. Sometimes people get confused. I'm not taking the log, I'm taking an ln. No, they're the same thing. You're still taking a log, it's just with a base of E. Since E is just a number and ln is just a log, let's rewrite these guys. Let's take a look at e to the x equals 10, and let's realize that it can be rewritten as simply the ln of 10 equals x. E to the negative 3x equals 14 can just be written as the ln of 14 equals negative 3x. The ln of 4 equals x. Remember, ln is the same as saying log base E. So E to the x is 4. Likewise then, this last one, the ln of x plus 2 equals 5 would be E to the 5th equals x plus 2. If our logarithm rules continue to work, then we should be able to rewrite the ln of 216 minus 2 ln of 6 the same way we would have done anything else. We'd have the ln of 216 minus the ln of 6 squared. ln of 6 squared becomes the ln of 216 minus the ln of 36. If we're subtracting two logarithms, that'd be the same as the logarithm of a division. And if we have the division, we can find out that 216 divided by 36 is simply the ln of 6. Try this one with a variable instead. We could rewrite this by putting both of these coefficients up as exponents, giving us the ln of x to the 5th plus the ln of 3 to the 4th. 3 to the 4th would become an 81, so we have the ln of x to the 5th plus an ln of 81. And since we're adding logarithms, we can make it into a single logarithm of a multiplication of 81, or a product of 81 and x to the 5th. So ln of 81 x to the 5th. How would this look if we were to expand things? Well, use the same rules. We can take a multiplication inside a logarithm and split it into the addition of two separate logarithms. And you can see that doing this, we've looked at this in the past, but it allows us to separate parts that we can calculate and parts that we might need to solve for. So we'll drop the 3 down in front. We have a 3 ln of x. This would be how we could expand that. Let's try solving. And in order to solve, we want to get our e to the x by itself. So let's add 3 to both sides. Take our 5e to the x, set it equal to that 32. Then let's divide both sides by 5. When we divide both sides by 5, we're left with e to the x equals 32 fifths. Now we can take the log of both sides, or the ln of both sides. If we take the ln of both sides, the ln of e will cancel and leave us with an x. You can think about dropping that exponent down in front. If that helps, that would be fine. And we're left with the ln of 32 fifths. If we wanted an exact answer, this would be it. If we wanted an approximate, we could punch that into our calculator and get an approximate of 1.856 rounded to 3 decimal places. Let's take a look at another example. we'll start by subtracting 5 from both sides and get a 4e to the 2x equals a negative 2. And we can take and divide both sides by 4 and get an e to the 2x equals a negative 1/2. Can you take a positive value, raise it to an exponent, and get out a negative value? Negative exponents don't give us negative values. They give us reciprocals. They give us things in denominators. They do not make things negative. Likewise, if you don't recognize that at this point in time, make this into an ln of negative 1/2 equals 2x. You cannot take the ln of a negative number for the same reason that we were just discussing when we were talking about negative numbers coming out of exponents. You cannot take the negative, a log, any log, and ln included, of a negative number. So what do we have going on here? Well, we have a no solution situation. There is no solution to this equation. Let's take a look at just a couple more equations. If we take a look at our 3e to the 2x, and if we added 2 to both sides, we would get that equal to 7. And dividing both sides by 3, we can find out that e to the 2x is equal to a 7/3. And now, either by rewriting in logarithmic form or taking the log of both sides. We took the log of both sides before. Let's just think of this as rewriting in logarithmic form. In other words, we'd take ln, or log base e, of 7/3 and set that equal to 2x. If we divide both sides by 2, we get x equals the ln of 7/3 over 2. Now that would be our exact answer. If we wanted an exact answer, that's what we would have to use. If we punch that into a calculator to get a decimal approximate, we would find out that we would have 0.424 as our value for x. Our last example here is something that we have been able to do before. We did this the other day, taking the log of both sides, but now we could do this with an ln instead. The ln of 5 to the x could equal the ln, or does equal the ln of 9, which means we have an x ln of 5 is the same as the natural log of 9, and if we divide both sides by the natural log of 5, we'd get the natural log of 9 over the natural log of 5, and that decimal approximate would be 1.365. As you can see, going through this example and the other ones, the natural log, very useful. It, once again, like a common log, can be found on most scientific calculators, and you can use it to do a change of base, just the same way we did with common logs the other day. You can use it to solve equations with exponentials, like we did in this example right here. And it can be used many other places as well, and we'll find some of those out as we continue.